Maths Aspirants groups organizes several online problem solving sessions to help the students, those who prepare for competitive examinations. In this series of problem solving sessions, today we have Mr. Vishnu Raveendran is with us. He is now doing Ph.D. at Karlstad University, Sweden. He completed his B.Sc from Tata Institute of Fundamental Research with TIFR GS Scholarship. He will discuss some problems from the basic calculus, functions of one real variable. I would like to express my thanks to Vishnu for being with us. I welcome everyone to this program. Welcome, Vishnu.
First of all, I would like to thank Vinod sir for considering me for giving a talk here, and all of you for attending this class also. So basically, I plan to do the functions of one variable. Mostly I will do problems in section limits, and if I have time, I will do some problems in continuity also. So I will focus mainly on theoretical problems and one or two computational problems. So I think I can use this hand cam here, right? So we'll discuss some problems from limits, and one second. So I will not talk much about the theory section. We will recall some definition and property from limits, and then we will move to the problems. So I hope everybody knows this basic definition and everything. So I will do it very quickly without much explanation. Then we will move to the problems. So let's recall some important results from limits. First of all, I would like to give the definition of limit. So the definition is that we say a function f defined from an open set to R has a limit at limit L at x naught. We represent limit x going to x naught f of x equal to L if for every epsilon greater than 0 there exists a delta greater than 0 such that f of x minus L less than epsilon if x minus x naught less than delta. So this is the definition. Yeah, there is actually a mistake in this definition. So anyone can spot here what's the mistake here?
This x minus x naught will be not equals to 0.
Yeah, exactly. So we need like x, we don't need x equal to x naught. So you can either give x not equal to x naught or just give 0 greater than less than x minus x naught. Yes, so let's recall some properties. The first one is local boundedness. What it says that if f of x goes to L as x goes to x naught, then f is locally bounded in a neighborhood U of x naught. That means f of x, for f of x you can find a bound for any x in a open set, a neighborhood of x naught. This I'm sure you guys saw this thing, so I'm not giving the proof and everything. So we'll just recall this thing and we'll move to the problems. Then the second thing is that constancy of sign. Says that if f of x converging f of x goes to L as x goes to x naught, and assume if L is greater than 0, then there exists a neighborhood U of x naught such that f of x will be positive for all x in that neighborhood minus the x naught. What it's saying is that if you have a limit like fx goes to L at x naught, then on the neighborhood of x naught, f will be positive if L is positive. You can do it the other way also. If L is negative, then you can find a neighborhood of x naught such that f is a negative on that neighborhood. Then some standard result which says if limit x going to x naught f of x is L1 and limit x going to x naught f of x, another function g of x is L2, then we have some standard result. Limit x going to x naught f of x plus g of x equal to limit x going to x naught f of x plus limit g of x. This may look some similar, but while doing some problem, we will come again to this theorem. So you can see some, we will discuss it better. Similarly, limit x going to x naught f of x into g of x equal to limit x going to x naught f of x into limit x going to x naught g of x. And another thing, f by g. This also follows the same type of rule. Limit x going to x naught f of x by limit x going to x naught g of x. By providing this limit x going to x naught g of x not equal to 0, then only it's defined. And yes, we have another property which is sequential criteria, or some people call it Haynes criteria, which says that if limit x going to x naught f of x equal to L, we can write as if and only if statement such that if any sequence xn such that xn converges to x naught and xn not equal to x naught, limit n tends to infinity, this sequence will be equal to L. So this is not actually the proper statement, but I just want to give you the idea. So if these both statements are equal, like if you have limit x going to x naught f of x equal to L, then if you take any sequence that converges to that point, then if you take limit of n tends to infinity f of xn also will be equal to x. Now we will discuss one more property, then we will move to the problems, which is squeeze theorem. I'm not going to write the full statement, but the idea is that if you have three functions, say g of x less than or equal to f of x, less than or equal to h of x. And if you know this, g of x will converges to L as x going to x naught. And you also know this h of x also going to L as x going to x naught. Then it will automatically say this f of x also will go to L as x going to x naught. So this is the idea of squeeze theorem. I'm not going to discuss the whole statement, but we only need this much actually. Yeah, so now we can move to the problems. So before that, any questions or comments related to what we done until now? Yeah, if no, then we can start doing problems. We will we'll start with one of the easiest problem. Give an example of a function without a limit point, without a limit at any point, and then f is defined on R to R. So the question is that you need to give an example for a function so that the function at any point on the domain, the function does not exist a limit actually.
Dirichlet function.
Yeah, exactly. Or Dirichlet function. You can construct many functions like this. So one, for example, one is like you define f of x equal to -1 at x element of Q, and 1 if x element of Q complement. Q is the rational number and Q complement is the irrational number. Yes, but we need to explain also like why it is limit does not exist at any point. So you take any point in R real number. So we use the sequential criteria here. If the limit exists at x naught, then any sequence xn converging to x naught, the limit also converging to the limit of that sequence also converging to L. So we took an x naught in R, and we can always find a sequence xn which is a rational number, and xn converges to x naught. Also there exist yn irrational numbers such that yn converges to x naught, because x naught is a point in real number, and you know these rational numbers are dense in real numbers, so you can always come up with a sequence which converges to that point. Also irrational numbers also dense in real numbers, so you can find a sequence which converging to x naught. So if the limit exists, then limit x tending to x naught f of x should be equal to limit xn going to x naught limit n tending to infinity f of xn, and limit n tending to infinity f of yn also by the sequential criteria. And what is this? This is f of xn, and xn we chooses from rational number. So for rational number, this value will be -1, and for yn we chooses from Q complement. So f of yn will be +1. So the limit will be just +1. So we get -1 equal to +1, which is not true. So we conclude that the limit does not exist. Yes. So any questions related to this problem? Anything you can ask. If there is no question, then we can move to the next problem.
Dear
okay.
students, yeah, Vishnu. Dear students, if you have any doubt or anything to comment, you can do it in between. No problem. Okay. Yes, Vishnu.
Yeah. If it is some nonsense also, please ask so that we can discuss. So let's move to the next question. Limit x going to 0, root x sine e to the power 1 by root x. Find the value of this thing, this function. So anyone have any idea how to approach this?
Sir, since sine e to the power 1 by root x is bounded, we can say that the value is 0 since root x tends to 0 and the value of sine e to the power 1 by root x is bounded.
Yeah, exactly. The idea is that, but to be more precise, like we can use here the squeeze theorem. Yes, what you told is correct actually.
Okay, sir.
Yeah, we know this. Okay, sin x always you can bound by -1 and +1, right? So whatever the value of x it is, so we can bound sine of e to the power 1 by root x. That also we can bound by 1 and -1, right? Now we multiply this with square root of x. What we get? We get minus square root of x less than or equal to square root of x sine e to the power 1 by root x less than or equal to square root of x. Now we use our tool, which is the squeeze theorem. So we have this function we can bound by root x and minus root x. Now we know as x goes to 0, minus root x also will goes to 0, and plus root x also will goes to 0 as x going to 0. Now this squeeze theorem, what is saying? The middle function will also automatically goes to 0 as x going to 0. So we get limit x going to 0, square root of x sine e to the power 1 by root x also equal to 0. Any questions for this or comments? If you have some better idea also, please tell me so we can do that also. Okay. Okay, then we can move to the third problem, which is just to state true or false. The first one is that limit x going to x naught f of x plus g of x equal to limit x going to x naught f of x plus limit x going to x naught g of x. And the second one is that limit x going to x naught f of x into g of x equal to limit x going to x naught f of x into limit x going to x naught g of x. So this is my question. State whether it's
False.
true.
If the limit exists, then only we can say it like that, no?
Yeah. Okay.
It's not given that the limit exists.
Yes, exactly. But can you construct a counterexample for this? when two functions which does not satisfy this condition. So for others like
Sir, x sine 1 by x.
and minus 1, right?
sorry, what?
Sir,
Sorry.
B question, x sine 1 by x. Limit x tends to 0, x sine 1 by x.
X sine 1 by x. Okay, this one. This limit x is right.
Limit x tends to 0. So we cannot write this as limit x tends to 0,
Yes, exactly.
x into.
Yes. Yes, so for the others who did not, so the answer for this, the statement is actually false, because in the beginning we discussed this theorem related to, yeah, there it is. Yes, we discussed this theorem in the beginning, but in that place we need one extra condition. We need this limit should exist for g of x and f of x. But in this case, we just stated without the existence of f of x and g of x. So the answer is false. And the counterexample one she given is that limit x going to 0, x sine 1 by x. If this is true, then it should be limit x going to 0, x, and limit x going to 0, sine 1 by x. This is actually 0. I hope this is fine with everyone, because it's pretty much standard function. And this is 0, but limit sine 1 by x, x going to 0. This does not exist. And can anybody give the example for the first one? F of x plus g of x.
For this, we can take a limit x goes to 0 and fx equals to 1 by x and gx equals to 1 by minus 1 by x.
Yes, exactly. Yes, you can take fx equal to 1 by x and g of x equal to minus 1 by x. So fx plus gx, you will get the constant function 0, but limit x tending to 0, f of x and g of x does not exist. Yes. Okay, so anybody have anything to add with this? Or not understand anything?
Clear, sir.
Yeah. Okay, then we can move to the next problem. Please also state true or false. Let f g from real number to real number are two periodic functions. Satisfying limit x goes to 0, f of x, no, x goes to infinity, f of x minus g of x equal to 0. Then f and g have same period. So what the question is that you have a statement, you need to say it's true or false. The statement is that you have two periodic functions, f and g, with maybe different period, but there is a condition given, which is limit x going to infinity, fx minus gx will be 0. Then the question is that f and g have same period or not. So before that, I would like to, for those who don't remember what is periodic function is a function where you can, with where you can write f of x plus t is equal to f of x for all x in R or in the domain. Here we call t is period. And we have a function f and g satisfying periodicity property. Now the question is that this t1 and t2 are same or not if you have this condition, limit x going to infinity f of x minus g of x equal to 0.
Yes, sir.
I think it's false.
It's false. Okay, why it's false?
We can take fx equals to sin x and gx equals to sin 2x.
Yes, so will it satisfy this condition?
Oh, sorry, no.
Yes. So sin x and sin 2x you mean, right? So but this type of function, like first I would say, like you can just try to plot and understand how these functions behave. Like for example, sine will be more like this and sin 2x will be little more thing, but anyway it will not be equal at x going to infinity. This statement say that x going to infinity, f and g will be same. Anybody have any other idea? Or convex only? Yes, so no, actually the statement is true. And it's even more strong that I will discuss in the end. But anybody have any guess how to prove this? Or so the basic idea is that you need to prove either one of these. One thing you can prove this t1 equal to t2, or the second thing is that f of x plus t2 will be equal to f of x. This means f have period t2. And the third condition is that g of x plus t1 equal to g of x. Because we already know this f of x plus t1 equal to f of x, and g of x plus t2 is equal to g of x. These are the given condition. And if you can prove either one of these, then we say that f and g have the same period. So this means that f has the period t2, and this means that g have the period t1.
So can we use limit f of x extends to infinity, f of x is equal to limit of g of x? Can we substitute that?
Yes. Yeah, basically you need to do that, but okay, just let's write what you're saying. So limit x going to infinity, f of x
equal to g, limit x to infinity, g of x.
G of x. Yes, actually we need to use this somewhere.
Limit it implies from the given condition that this is true. So then f of x is plus at infinity, f of x plus t1 equal to f of g of x plus t2. That is periodic function only one period, no, right?
No, actually.
Period is the least multiple, so it should be one equal, no, t1 equal to t2.
Actually, I did not understand. So you're saying like we can take limit here also and
Yes.
limit here also. But from here, you cannot conclude like t1 equal to t2, right?
Sir, if it is a continuous function, it has only one period, right?
But we don't have the continuity.
Not a continuous function, not periodic function, I meant, sorry.
Yes, periodicity.
It's unique, right?
No, sorry, I'm not understanding.
That is, sine has only one period, 2 pi, right? No another period.
Yes.
So if I take x is equal to infinity, if it is f of x plus t1 equal to f of g of x plus t2, right?
Yes. At x going to infinity, yes.
Then we can be not write t1 equal to t2.
No, we cannot write that actually. Because this is not a fixed number. This is x going to infinity actually.
Okay.
This is actually we take limit. So yeah, this is actually okay. So this is, I would say, not an easy problem, but okay, let's see how we do this thing. So we have x naught plus nt1 plus t2 minus g of x naught plus nt1 plus t2. What is this actually? We know this f have period t1, right? So this whole term we can just write as f of x naught plus t2. And g have period t2. So this whole term we can write as g of x naught plus nt1. This is okay, right? If I'm doing some mistake, please correct me, okay? Yes. Now we take limit n goes to infinity. So what we have limit n goes to infinity f of x naught plus nt1 plus t2 minus limit n goes to infinity g of x naught plus nt1 plus t2 equal to, there is no n here, so you don't need to take limit here. It will be just f of x naught plus t2, and here limit n tends to infinity g of x naught plus nt1. This is okay, right? If you're not understanding, let me know. I can explain it one more time also. So what I done, I just write this thing and take the limit. So I have the condition that limit x going to infinity f of x minus g of x equal to 0, right? So that I will use here. So limit n going to infinity, this whole term will goes to infinity. Similarly, this also goes to infinity. So this is basically, you will get limit n x going to infinity f of x minus g of x. So this left hand side completely will become a 0. So what I'm saying is that you will get 0 equal to f of x naught plus t2 minus limit n going to infinity g of x naught plus nt1. By using this condition, the left side will go to 0. Now, if I can prove this term, so what I got f of x naught plus t2 is equal to limit n goes to infinity g of x naught plus nt1. This I have. Now, if I can prove this is nothing but f of x, then I am done, right? So if I can prove, okay, so this I keep it here. So now let's look what is this limit g of x naught plus nt1, what it is. So from this condition, we know limit n going to infinity f of x naught plus nt1 minus g of x naught plus nt1 is equal to 0, right? Because this is from the question, we have this limit x going to infinity f of x minus g of x equal to 0. So I'm using that here, so I get limit f of x naught plus nt1 minus g of x naught plus nt1 goes to 0 as n goes to infinity. but f have period t1, right? So this is I can again write limit n tend to infinity f of x naught. So this first term will be just f of x naught and g of x naught plus nt1. So from here, what I get, you can take this limit inside, limit n go into infinity, g of x naught plus nt1. So I got f of x equal to limit n going to infinity, g of x naught plus nt1. That term you can see here also, limit n going to infinity, g of x naught plus nt1. So what we got? We got f of x naught plus t2 is equal to f of x. So f is t2 periodic. Hence our statement is actually correct. F and G have same period. Any questions related to this thing?
So I have a question. Can we use one by limit? Can we write? We know that limit extends to infinity f of x is equal to limit extends to infinity g of x, right?
Yes.
Then can we write a limit extends to 0 f of 1 by x equal to limit extends to 0 g of 1 by x?
Limit extending to 0?
F of 1 by x
Yes.
equal to limit extends to 0 g of 1 by x.
0. Yes, we can write like.
Is this valid?
Yes.
Then can we not write that 1 by x plus t1 equal to f of that if 1 by x plus t1 equal to 1 by x plus t2?
X plus t2. Oh, this I'm not understanding. No, actually, the thing is that this is actually you taking the limit actually. You are not fixing the value x here. So if you have, I would say that. So this is your question, right? From here you can write like this or not?
Yes.
But you cannot write like this actually. Okay, how would I give some example?
So can we split the limit like that? Because we don't know that limit extends to infinity f of x or limit extends to infinity g of x exist. So can we split like that?
Good question. Yes. Let me think for a second. So you mean like we cannot split like this? So 1 second. Yes, that's actually true. To split like this, we need this limit exist. But do we need to split here anywhere? That's what I'm looking actually. In our case,
I think in the proof it is not used.
we do not use that.
Yes.
Yeah. Yeah.
The last part when we take f of 1 by x.
Okay, here you mean. Yeah. Yes, here you cannot split it like that. That you mean, right? You can write limit x going to 0 f of 1 by x minus g of 1 by x equal to 0. This you can write, but limit x going to 0 f of 1 by x equal to limit x going to 0 g of 1 by x. This we cannot write from this. Okay, because we cannot split it. Yeah, that's a good point actually. Thank you. So still any confusions? Or?
So further we can conclude that fx equals to gx for all x, right?
Yes, exactly. That's good. we can conclude that fx equal to gx. So anybody, you have any idea how to do that thing? So the comment is that note, in this case, like if, yeah, what I want to say, if you have this condition and limit f of x minus g of x equal to 0, we have one more thing, that f equal to g. So anybody know how to prove that thing?
Yes, sir.
Yeah.
If a point A belongs to R, then we can take the sequence xn equals to A plus Tn, where T is the period. And then xn goes to infinity.
Yes.
Then
plus,
limit n goes to infinity, f of xn minus g of xn equals to 0. From that we can get f of A equals to g of A.
yes, exactly. And so the thing is that now we know f and g have the same period, right? So if you take any point in R, we can write f of A equal to f of A plus nt and g of A equal to g of A plus nt. Okay, so this is not right. F of A equal to f of A plus nt, g of A is equal to g of A plus nt. Now f of A minus g of A equal to f of A plus nt minus g of A plus nt. This you can write, because now we know that we already showed that f and g have a common period, which I call as just a t. Now f of A I can write as f of A plus nt for any natural number n, and g of A I can write as g of A plus nt for any natural number n. So f of A minus g of A I can write as f of A plus nt minus g of A plus nt. Now I can take the limit on both sides. So the left side, it will be same, f of A minus g of A. Now in the right side, f of A plus nt minus g of A plus nt. Yes. So by this condition, as x going to infinity, f of x minus g of x equal to 0. We know this, as n goes to infinity, this will also go to 0. So we get f of A equal to g of A for any A in R. So we conclude that f equal to g. So this we get as, yeah. So if we have a periodic function and if we have this condition, x going to infinity, f of x minus g of x equal to 0, then f and g should be equal. Any questions related to that?
Clear, sir.
Clear, sir.
Yeah, okay. Okay, then we can move to the continuity part. So before that, if you have any problem related to limit, you can ask now. So we just recall the definition of continuity. If f defined on an open set, subset of R to R, f is a function defined on I, and C is an element in I, we say f is continuous at C if for any epsilon greater than 0, there exists delta greater than 0, such that f of x minus f of c less than epsilon if x minus c less than delta. So this was the standard definition for continuity. And yeah, I will not recall all the theorems related to this, but I would like to recall one important theorem, which is intermediate value theorem. We will use this to do some problem. That's why I'm doing this. So the statement is that f is a continuous function. F defined on an open set be a continuous function. And if a comma b are element of I, and if you have f of a less than k less than f of b, then there exists a C between a and b such that f of c is equal to k. So this was the statement for intermediate value theorem. Yeah, we will use this theorem only for the problems, not much things. So we can start the problem. I'm sure, I hope that everybody knows these things, so I'm not explaining much actually. So if anybody need much more explanation, we can do that also. So we start with a true or false question. State true or false. Let f from R to R is a continuous function. Satisfying the condition f of x plus f of 2x equal to 0. Then there exist infinitely many such functions. So the question is that you need to say it's true or false. The statement of the statement is, I have a function, I have a continuous function defined from real number to real number satisfying this condition. And my statement is that there are infinitely many such functions satisfying this condition. So that's the question. What do you think? Anybody have any idea? Or anybody know how to approach this question? Like, what would be the steps at least? But we need to check this type of problems. We can take some time. So if you get such a condition, what you will check first? Like, so from this, can you get something, like some value at least? Anyone? Yes, so I can give you the first one.
F of 0 should be 0.
Yes, that will be the first observation. So the first observation is you can check for 0, because if you put 0, f of 0 plus f of 2 into 0, that will be 0, right? That means f of 0 plus f of 0 is equal to 0, which implies f of 0 equal to 0. This you got. Yeah, this is the first observation we need to make. Now what? Now
F of x equal to f of minus f of 2x.
f of
X equal to minus f of 2x.
minus, yes, that was it, correct. Yeah, yeah. Okay, yeah. So again, you can
It
do
will
it.
be a bounded function.
Yes, it will be a bounded function, but yes, it will be a bounded function. But can you say like how many of, like, are they infinitely many or not?
F of x equal to minus f of x by 2.
Yes, that also equal to minus of f of x by 2. Okay, yeah, we need this observation actually. So this at least, I hope everybody knows this, because f of x plus f of 2x equal to 0. So we get f of x equal to minus f of 2x. Again, we know this f of 2x plus f of 4x equal to 0. Because instead of x, I put 2x. So I will get this. So what I get, f of 2x will be minus f of 4x. So f of minus f of 2x will be minus 2 times minus f of 4x. And again, I can do like this. So it will be minus 1 to the power 3 f of 8x. So I can go like this up to minus 1 to the power f of 2 to the power n x. This is okay, right? This is another observation you can make from here, because what I done is that at the first I got f of x equal to minus f of 2x. Then I, in our equation, I replace x by 2x. So I get f of 2x equal to f minus f of 4x. Then what I done, I replace x by 4x. So I get f of 4x equal to minus f of 8x. So if I do continuously, I will get f of x equal to minus 1 to the power f of 2 to the power n x. So this is one observation you can make from here. Now, from here also, here instead of x, I can put x by 2, right? So if I put x by 2
the
here,
function should be identically 0.
yeah, yes, the function will be 0.
Because if you take any real number a, then you will get f of a equal to f of a by 2 equal to f of a by 4 equal to f
Yeah.
of a by 8 in such a way.
Yeah.
Then see that, please note that a by 2, a by 4, a by 8, this sequence tends to 0, right?
Yes.
So you are something like getting the sequence f of a by 2 to the power n equal to f of a. So if you take limit on both sides, you will get limit n tends to infinity f of a by 2 to the power n equal to limit n tends to infinity f of a. As it is continuous, we can take such a limit and it is valid, right? And f of a by a by 2 to the power n is a sequence that tends to 0, right? So limit n tends to infinity, f of a by 2 to the power n will be f of 0, as a by 2 to the power n tends to 0, and we got f of 0 equal to 0. So
Yes.
f of a equal to.
Yes, exactly. That's what we do. Same idea. So similar to this, you get f of x equal to minus f of x by 2. Exactly what he said. Because if I replace x by 2, I will get f of x by 2 plus f of x equal to 0. So f of x will be minus f of x by 2. Now I can replace x by 4. So similar, I will get here minus of f of x by 4 and equal to, I can do this iterative way. So it will be minus 1 to the power n f of x to the x by 2 to the power n for any x. So what I got f of x equal to minus 1 to the power n f of x by 2 to the power n. from here by iteration. And this we know, x by 2 to the power n. This will go to 0 as n goes to infinity, right? This is a sequence which converges to 0, and f is a continuous function. So we can take the limit here, f of x, limit n tends to infinity, minus 1 to the power n, f of x to the power 2n. So this will be goes to 0. So you get f of x equal to 0. So at the end, you get your function f will be just a 0 function. So there will be only unique function. There will be only one function satisfying this condition. F of x plus 2x will be 0. That will be just 0. Okay. And
Okay, sir.
yeah, questions and comments, please ask. Yeah. Okay, then these yeah, just it's a very simple problem. State true or false that image of a continuous function defined on bounded set is bounded. You need to say it's true or false. This is pretty much easy, I would say.
It's false.
Yes, it's false. Can you give a counter example?
Fx equals 1 by x in open 01.
Yes. Fx equal to 1 by x in open 01. This is actually bounded interval, and f of x is a continuous function, but this is not a bounded function. Image of f of x will be 0 to infinity or 1 to infinity. So this statement is false. Yes, let's move to the next problem. Okay. Yes. Again, like state true or false. Let x is a positive, then there exists a unique solution for the polynomial x to the power n, x to the power n minus 1 plus x to the power n minus 2 plus up to x minus 1 equal to 0. This is our question. We have a polynomial of order n, and n is a natural number.
Yes, sir.
Yes. So can you give the explanation? The answer is actually correct. It's true.
Descartes' rule of sign.
Which one?
Descartes' rule of sign, we can say that there's just one variation. So we have one positive root for this polynomial.
Yes. Maybe, but I don't remember what was the rule of sign. Yeah, that can work here. But can you give some other explanation? Like, yeah, that will work, but you can do it in some other way also. You can give many way, but can you do this by intermediate value theorem? Yes,
By continuity of polynomials.
Sorry, what?
So when x is equal to 0, we have f of 0 equal to minus 1.
Yes.
If there are two solutions, we can just use intermediate value theorem or something like that.
Sorry, I couldn't hear actually. Can you repeat? Yeah. Okay. So we define this function fn, and it's pretty easy, I would say. Like, you can see that fn of 0 will be -1, which is less than or equal to 0, and fn of 1, if you put 1 instead of x, it will be, there will be n times 1, so it will be n minus 1, which is greater than or equal to 0 because n is a natural number. So by intermediate value theorem, I just shortly write I by t, there exists a number a between 0 and 1 such that fn of a is equal to 0. Yes. So this says that there exists a solution, but you need to say it's unique or not. So this gives there exists a solution in 0 to 1. So how can you say this is unique or not?
We can use
take
the
the
Rolle's
derivative.
theorem.
Sorry?
The Rolle's theorem. We can use that.
How you say that?
If there exist two positive solutions A and B,
Yes.
then its derivative should have a root in between A and B.
Yes.
But if we compute the derivative, that is always greater than 0 in positive if x is positive.
Yes. Yeah. It will be. Yes. Exactly. Yeah. That is one way. Yeah, that will work. And there is. Yeah, exactly. You can say, and then there is much more easier argument you can give. You can see that this is
If
just
there are
a,
like two roots, we can get f of a minus f of b equals to 0. So the corresponding a minus b, a raised to n minus b raised to n, and all that factors would equal to 0. Can we do something like that?
actually, I couldn't listen properly. So you mean like if you have two roots, then assume you have this function, you have two roots, then the derivative will be 0 at some point. Well, I do not understand the question actually. But this is actually pretty much simple. You can see that this is just increasing function because x is a positive number, and it's 1 1 also. No, sorry, increasing and continuous. Strictly increasing and continuous, this function. So for strictly increasing and continuous functions are 1 1. Just 2-3 line argument you can do.
So it will cross the x-axis only once.
Sorry, what?
F of 0 is -1 and f of 1 is greater than or equal to 0. We will get something like that. So it will cross the
Yes.
x-axis with only 1 point.
Yeah, exactly. Because it's increasing function. That's why. Because f of 0 equal to 1 minus 1 and f of 1 equal to positive number gives only that there exists some root which you can, like, there exists one solution only. But to show that it's a unique one, there is only one solution. You need to prove like fn is a 1 1 function. So to prove the 1 1 function, you can just argue by like fn is increasing, strictly increasing, and continuous. So it will be 1 1. That argument is okay, right? Or if I'm making some mistake, please correct me. I may do some mistakes.
So we not use the derivative is positive and hence it is increasing.
Yes, that also true. Yes, exactly. That also you can use. Yeah, in every problem you can do in many ways. So yeah. Let's move to the next problem. This is also state true or false? F defined on R to R is continuous and periodic with period 1. Then there does not exist x naught in R such that f of x naught plus pi is equal to f of x naught. So this is the question. You have a continuous periodic function which have period 1. Then the statement is that there does not exist a point x naught such that f of x naught plus pi equal to f of x naught. Anyone have any idea? So I would say this here also you need to, one way to think of this by intermediate value theorem.
False. Statement is false.
Statement is false. Why it's false?
If we take a constant function,
Hmm.
then clearly there is some x naught such that f of x naught plus pi equal to f of x naught.
Yes. It's periodic. Yeah, constant function will satisfy this thing.
But a constant function doesn't have a fundamental period, right?
But you can consider it as a periodic function because it will repeat the value, right? Yeah, you cannot find a fundamental period, but any number is a period actually. Because you can say like f of x plus 1 will be f of x for any x. But I would, this is not a fundamental period, but it's still a period. Understanding? For constant, if f is constant. Yes, I think it's, yeah, you can consider this as a periodic function, but and then it will follow every property of a periodic function also, the constant function. So okay, now let's change this problem again. F is a continuous function with periodic 1, then there exists x naught element of R such that f of x naught plus pi equal to f of x naught. So it will be obviously true, but you need to give a justification why it's true. Because constant function is just one example here. So now the question is that the statement is f is a continuous periodic function with period 1, then there exists x naught in R such that f of x naught plus pi is equal to f of x naught.
F of x is a continuous periodic function in closed interval 0, 1.
Okay.
So f is uniformly continuous there.
Yes. It's uniformly continuous on close your own. Exactly. But how you end up with this statement actually?
So f attains its bounds at some points a and b belonging to closed interval 0, 1.
Okay.
So f of x less than or equal to f of a for all x belongs to R.
Let me write it. So you say like there exists a in 0, 1 such that f of a will be maximum of
f of x.
x element of 0, 1, and if there exists a and b, and f of b is equal to maximum of f of x on x element of 0, 1. This is what you are saying, right?
Yes.
Yes. Now what we do?
If we take a function g of x equal to f of x plus pi minus f of x. X plus pi minus f of x.
So, but here one more step we can do because of its periodic function. We can write it as maximum of x element of r f of x, because this function repeat from it have a period 1, so the maximum value attains in the interval close 0, 1 will be the same as maximum value in the whole real number. Similarly, minimum of x element of r f of x also f of b. Now what she suggested is that we can define a function g of x equal to f of x plus pi minus f of x. So if we are able to prove like there exists a point g of like t naught such that equal to 0, then we get f of t naught plus pi minus f of t naught equal to 0, or f of t naught plus pi equal to f of t naught. So our aim is to prove this thing actually, right? We need to find a point t naught or x naught satisfying this condition. So for that, it's enough to prove this g have a solution. For that, we'll use the intermediate value theorem. But so let's see what is g of a. So g of a will be f of a plus pi minus f of a. And you know this f of a will be the maximum of f. So f of a will be the maximum of f. So f of a will be greater than or equal to f of a plus pi. So this will be less than or equal to 0 because this is the highest, bigger number. Similarly, if we check what is g of b, it will be f of b plus pi minus g of b. So not g, f of b. Okay, I'll write it in nicely. F of b plus pi minus f of b. So we know this f of b is the minimum of f of x all over the R. So f of b is the minimum number, so it's the smallest number. So f of b plus pi minus f of b will be greater than or equal to 0. So we got 2 points a and b, such that g of a will be less than or equal to 0 and g of b will be greater than or equal to 0. So by using intermediate value theorem, we have there exists a t naught or x naught between a and b such that g of x naught is equal to 0 by using the intermediate value theorem. So what we have g of x naught equal to 0 means f of x naught plus pi minus f of x naught equal to 0. This implies f of x naught plus pi equal to f of x naught. So this is true actually. Yes, so the statement is true. Any questions? So these.
So can A and B, should A and B be distinct or can there be equal?
If they are equal, then it will be a constant function, right? Because f is a periodic function and continuous function, its maximum and minimum are equal. That means f is just a constant function. In that case, you will get f of x naught plus pi will be the constant, minus f of x naught will be 0. So
Oh.
here it can be distant or same also, doesn't matter.
Okay.
Yeah. Yes. So let's look some other problem. Let's do one more similar problem. Again, state true or false. Let f comma g defined on closed interval 0, 1 to 0, 1 be continuous function such that maximum of x in 0, 1 f of x will be equal to maximum of x in 0, 1 g of x. Then the exists t naught in 0, 1 such that f cube t naught plus f of t naught is equal to g cube t naught plus g of t naught. This is a statement. So you need to tell me whether this is true or false. So we have two continuous function f and g defined on close 0, 1 to close 0, 1, and it's given that it's continuous, and maximum of f and maximum of g are equal on that interval. So the question is that, is it true that f cube t naught plus f of t naught equal to g cube t naught plus g of t naught?
True, sir.
Yeah, it is true. And yeah, so how you do this? This is also the similar type of problem which we done the last problem. So can anybody say what we can do to prove this thing?
We can define a function h of x, sir.
Yes.
Maximum of f of x minus the maximum of g of x, and
Maximum,
find it 0.
maximum of g of x, then?
That's all if x belongs to 0, 1.
Okay.
Then we need to find its h of x, 0 of h of x, sir, by using interval equal to 0.
Yes. Yes, and is this continuous function? Maximum of f of x minus maximum of g of x. Because to use the intermediate value theorem, you need it continuous, right?
Yes. So it's wrong.
Yes. Actually, yeah, but this is actually not a function. This is actually a value. Because maximum of f of x will give you a number, and maximum of g of x will give you a number. So h of x will be just a number or a constant function. Yes, the idea is correct. You need to use the intermediate value theorem for this.
And h of x is equal to f of x minus g of x.
F of x minus g of x.
G of x is equal to h of x.
So this is your new h of x. Okay. So how we say this is, so how we proceed from here? So one I hope these also will work, but one better idea is that like you can, since this is a continuous function on closed 0, 1, we can explicitly find this x naught and y naught, there exists x naught and y naught, such that f of x naught equal to maximum of x in 0, 1, f of x, and g of y naught equal to maximum of x in 0, 1, g of x. And also, since it's given that maximum are equal, this f of x naught equal to g of y naught, right? Now we need to define this thing, h of x, like or like you said, like f of x minus g of x. Now we need to prove like yes, now we evaluate h at this x naught and y naught. So what will be the h of x naught? It will be f of x naught minus g of x naught. And we know this f of x naught is nothing but g of y naught from the condition. So it will be g of y naught minus g of x naught. And g of y naught is the maximum of g of x. So this is the bigger number here. So this will be greater than or equal to 0. Similarly, we can check what is h of y naught, which will be f of y naught minus g of y naught. And we can use this g of y naught equal to f of x naught again here. So it will be f of y naught minus f of x naught. And this f of x naught we define like maximum of f of x, right? So f of x naught will be the bigger number. So this will be less than or equal to 0. So we have a continuous function h of x, and h of x naught is greater than or equal to 0, and h of y naught is less than or equal to 0. So by intermediate value theorem, there exists a t naught between this x naught and y naught such that h of t naught equal to 0, right? So what it's saying? So it means f of x naught minus g of x naught is equal to 0, or f of x naught equal to g of x naught. Now, if you have this f of x naught equal to g of x naught, then it will also imply that not x naught, it is t naught. Yeah, for at t naught, f cube t naught plus f of t naught will be equal to g cube t naught plus g of t naught. So the statement is true. And any questions related to this? Anybody? Or any questions or any comments?
It's clear, sir.
Yeah. Okay, then I think we can stop now.
Yeah, Vishnu, if you have, you can do one more problem, but after that we can go for interaction.
No, it's okay.
Okay, then I think we can go for interaction.
So, is there any question until now? Like, any questions?
Okay. Thank you, Vishnu, for this session. Yeah. Vishnu, you can switch on your video. Yeah, that's fine. Okay, dear friends, now it is a time for interaction. Thank you, Vishnu, for this class. As you know, Vishnu is now doing PhD at Karlstad University, Sweden. So if any of you have any doubts regarding the class or regarding, and also Vishnu done his M.Sc at TIFR. So if you have anything to ask about TIFR or doing PhD abroad, you can do that. Yes.
Sir?
Hello.
Okay. Sir, my name is Amrita.
Mhm.
I'm a third year student in Devagiri College, Calicut. Sir, the topic you discussed was really very good, and limit and continuity. It was really very much interactive. We have seen so many classes, and I thought it was really interactive completely. Each and every problem you asked just the answer, and it was a two-way communication. So thank you so much, sir. And we expect more classes from you, especially from the other topics of function of one variable, differentiability, integrability, and all that topics. Thank you so much, sir. Thank you so for spending such time with us.
Yeah, thank you.
Thank you, Amrita. Others?
Hi, sir. My name is Meera. I'm from the same college, St. Joseph College, Calicut. I would like to show my sincere gratitude towards you for conducting such a good class and making it more interactive. The way you explain things of writing using a PDF was really giving us a feel of classroom. So it was really nice, and each and every problem was really well understood by us. And thank you so much, sir. And we are expecting more sections from you.
Thank you.
Thank you, Meera. Others?
Hi, sir.
Hello.
My name is Chandra.
Mhm.
Hello, sir.
Yeah, I can hear. Yes.
Sir, my name is Chandra. Okay. Sir, my name is Chandra. I'm coming from Devagiri College.
Okay.
And the class was very informative. And as mentioned, it was a very interactive section, very useful section. And we expect more classes from you, sir. Thank you so much.
Yeah, let's see. Thank you. And most of you from Deveri College, or? Yes.
Yeah, there are 5 or 6 students from Devagiri and other students also there.
Hello, sir.
Hello.
Sir, am I audible?
Yeah, now it's audible.
My name is Adira. I'm from Arts College, Calicut. Your class was very easy to follow. I got most of the points, and I expect many more classes from you, sir. Thank you, sir.
Thank you. You guys can ask some
Sir,
questions.
my name is Gopika.
Yes. Hello, Gopika.
Yes, Gopika.
Sir,
Yeah. Yes, I can.
yeah, okay, sir. I'm from Delhi University, final year student. So the class was very nice and informative. So it's a nice session, and we hope we can spend more time with you discussing. And thank you,
Yes,
sir.
sure.
Thank you so much for spending some time for us.
Thank you.
Hi, sir. I'm Namda Eldon from Kerala University campus. Sir, thank you for this interactive section, sir. Your class was very awesome. You explained each and every problems very clearly. Thank you so much, sir.
Thank you.
Others?
Sir, I'm Sindhu. Sir, it was really nice session. We are able to understand everything. See, sir, I want to ask something regarding your academic journey. Can you tell something about that?
It's nothing special actually. I just after my BSc, I actually didn't got anywhere for my masters. Like I tried for Calcutta University and some other colleges, but my mark was not enough. And so 1 year I prepared for this IIT and TFR, and I got in TFR. And from there I got here.
Yeah, Vishnu, someone in, yeah, Sindhu, continue.
Sir, how see, sir, you told that you've done your BSc in TIFR, no? Where you have done your BSc, sir?
BSc I done in Marapalli College. It's
Okay.
affiliated to Karlstad University.
Okay, sir. Okay, sir. Yes. Thank you, sir.
Vishnu, yeah, thank you, Sindhu. Vishnu, someone is asking in the message to give some idea about doing PhD in abroad.
Any questions in comments? Have you got chance for PhD in abroad? No, for me, like it's like I saw the advertisement and I applied with some good recommendation letters from my TIFR super professors, and yeah, and my professor here, who is my PhD supervisor, Professor Adrian Munde, he called me here for an interview, and I came to Sweden for 3 days to give an interview, and it went well, and I got selected. So now I am here. Yes.
Sir, can I ask one more question, sir? How you prepared for this interview, for this admission for the job?
No, interview, I would say like you don't need to study a lot of things actually. So what you are studying, that should be you should be very much clear about that. For in my case, like what I done is that I studied only one book, which is this real analysis by Bartle and Shepard, up to this uniform continuity part, and one group theory book. I forget the name. It was
maybe Fraley.
Not Fraley. Fallen
or Galley.
Sorry, I forget. It's
okay.
Does Fallen written some group theory book? Or? Yeah, whatever it is. But I would say like instead of studying lot of things, it will be better if you study what you're studying. It should be your base should be very clear actually. So I saw that many people there coming for TIFR interview, and they were saying like, please ask the question from topology or some other fancy subjects. But the thing is that it doesn't matter how much you know. The thing is that if you know something, you should be the master of that thing. So I was actually working on very short syllabus, but I was working hard on that actually in that short syllabus. And I think like for this master's entrance exam, these real analysis, group theory, and linear algebra is enough to get anywhere. Because if I understand correctly, the cutoff for IITs and everything will be around 40 to 50%, and these 3 subjects will be good enough to get you there. But it's good to know other topics also, but some topic you need to be very clear actually.
Okay, sir. Thank you for that nice explanation.
Others? Jaskaran from IIT Delhi is there.
There is for abroad. Somebody asked like process of getting chance in abroad. Yeah. So for getting in abroad, I would say you can try for masters itself. Like now many universities in Europe giving number of scholarships to study masters in Europe, and that's one way you can try to get a good master's degree in Europe. And if you are doing in some master's degree in India, try to do one good M.Sc thesis. So most of the process in Europe prefer like if you have a strong master thesis, then it will be easier to get the PhD in abroad. Not related. You don't need to be a high rank or high like good marks or anything. If your thesis is good, then that will be enough.
Your M.Sc project is more important.
Yes, M.Sc project is more important. Or you can do some summer projects in some good institutions also, because in this April-May time, these IITs and TIFR will call for summer intern programs actually. So you can go there for 1 or 2 months and try to do some good project. that also can help you to get in a good university in abroad.
Any other?
Hello.
Yes.
Yeah.
Hello, sir. Myself Lakshmi. I'm a third year BSc student studying at Martinish College, Kodamangalam, Kerala. First of all, I would like to thank you for this wonderful session. Actually, I haven't seen much problems based on this topic, period of a function and that function limit, the connection between both. So, thank you for solving such problems. Thank you so much.
And I included that because my research is related to partial differential equation and periodic function. So I try to include some periodic function problems also. Yeah.
Thank you, sir.
Thank you.
Lakshmi. Yes. Anyone else?
Hello, sir. My name is
Yes.
Anusri, studying in Kerala University. Sir, your session was really wonderful and informative because as you wrote in the paper and conveyed it to us, it was more a kind of classroom feeling. So that was very helpful, sir. Sir, there are some summer internships going on. So how should we apply for that, or how can we write that write-up for it? I mean, there is a 150 to 200 word limit write-up that we should prepare for that.
That I don't know, like one thing is that you can, but I will not prefer that. You can check for what the process are doing the research, and if you can connect your some topics related to that, like if you can just say, like if he's working on if one professor is working on research in partial differential equation, you can just say I'm very much interested in ODE and how I feel very good while doing this ODE and everything. So I don't know, I'm not a good expert to say what to write this type of things.
Oh, okay, sir. Thank you, sir.
Yeah. And thank you everyone for, like, it was good that it was in an interactive way, so that I can also.
Yeah, Vishnu, actually we have arranged many sessions, but in all that either they share a PDF or using some interactive board, and this is the
Is my internet have problem or? Yeah. Yeah.
Sorry, my connection. See, actually, what I to said is that in all the sessions that we have previously arranged, either they present by using a PDF or by using some electronic device. But this is the first time with a writing in a paper, so it's actually really a different feeling for the students. They really, I think they have considered it as a friend by sitting nearby to them and explaining the things like that. Such a feeling is there. Feeling was there. Okay, Vishnu, as we have many students from Kerala, and you have studied in a very ordinary college in Kerala, and then okay, slowly uplifted your career to a premier institute like TIFR, and then like a PhD abroad. Okay, all these things are dream for any student pursuing BSc now. So, what are the things that you wish to say to your juniors, especially from Kerala? You know the situation and the environment in Kerala, academic situations in colleges, all that you are very well aware about that. So,
yeah, that I would say our syllabus is kind of weak compared to, like, because I saw some syllabus of some universities in North India and West Bengal. They are like super good compared to the syllabus in Kerala actually. But anyway, like if you can work little more time, then it will be not much hard actually. And then I personally believe there is nothing related to your intelligent or anything. Like if you work few more hours than somebody else, then you are the better one. So
yeah, hard work and the attitude pays more.
Yes.
Okay. Any special advice to your juniors from Kerala?
I don't have any special
Not advice.
I
Not
give them all
advice.
the best.
Yeah, you can make some friendly remarks.
Yeah, I wish you all the best for everyone too, because I'm sure some of you become some good mathematicians after a few years. So yeah,
Let us hope.
yeah,
Let us hope.
I'm sure, like some
Of
of
course,
them.
of course, all of them are really motivated by achievements like peoples like you. So they will
No,
develop
actually,
such a.
I did not expect this will be kind of interactive way, because I actually teaching in Swedish university. Like here in my university also, I have some teaching job, but here the students actually will not interact much unless I'm teaching in a classroom. So I also didn't expect that it will be a interactive way, but thanks to everyone, like it went well. Yeah.
Okay. Yeah. Is there anyone else wish to make any comment or ask something? Otherwise, we can wind up here.
Yeah. Or if you have any question, you
Hi,
can
sir.
just contact me also. Yeah. Hi.
Yeah.
My name is Vaishnavi. I am a third year
Hello.
student from St. Paul's College, Karmashiri. Your class was very wonderful, and already everyone told that you have chosen some important problems from the periodic function, and it was very helpful for us. And can you tell me what was your experience from our university when you went up to a TIFR from our Kerala University? That our syllabus were very less. You have already told that our syllabus were very less when compared to that. When you went up to a TIFR, such a very high institute, what was your experience?
The thing was, in the beginning, it was a disaster actually. Like I was almost sure that in the beginning, like I'm not going to complete the masters there, but luckily I was in the beginning month I was working without sleep actually. Otherwise, because if you go there, like if some professor says some theorem, if you look around, everybody will prove that, and you will be I was the one who was looking around and looking what are they doing. So first 2-3 months it was very difficult actually. But the thing is that if you go to any university, like first month will be like that. After 3-4 months, it will be everybody will be kind of equal. Like if one can do the problem, you can also do the problem like that. Yes. So if you go in IIT also, it will be like that. Like in the first 2 months, it will be difficult, but then it will be okay.
Yeah, the atmosphere will be completely different from a college and an institute.
Yes.
So survival in the beginning time will be really a tough job.
Yes. No, but then it will be okay actually, because then
you will be tuned into that.
Yes. If you can stay there for 2-3 months, then it will be completely okay. You will be one of them actually.
Thank you, sir, and we expect more classes from you. Thank you so much.
Thank you, Vishnu. So I think we can wind up here. Thank you, Vishnu, for spending your valuable time with our students. Let us hope that our students will make good progress in their studies and will be able to reach into good institutes.
That I am sure at least some of them will reach.
Once again, I would like to thank you, Vishnu, for all your helps. So let us wind up here. Wish you all success in your studies. Thank you. Thank you, everyone.
Bye. Bye, everyone.
Bye.